Now, the connected masses questions that we've just looked at and that we saw in the exam occur where there's one mass hanging off the edge of a table. Okay, but actually they're very, very similar to a common situation and something that we have seen before. Ultimately, they're very similar to this kind of thing where we have two objects. So, say a car towing another car, or a tractor towing a trailer, or a boat towing another boat, something like that. This is a connected masses question as well. Okay, we still have this string here, so that these two things will accelerate at the same speed, at the same rate of acceleration, and we still have to work from the same through the same problems. The only main difference is where does the force of thrust come from? In the previous question, it was the force of gravity pulling down. But in a question like this, we'll say, okay, well, the motor of the car that's doing the towing provides a forward thrust of 2,000 newtons, for example. Okay, so let's examine this question to see if we can treat it in exactly the same way. Can we find the acceleration of both cars? Yes, we can. We go F net equals ma. Again, I'm assuming that we're in a frictionless environment here in this case. F net equals ma equals, now we use the combined mass, which is going to be 1,000 newtons, and the net force on the system, because there's no friction pulling it back, is just that thrust force of 2,000. Sorry. The mass is 1,000 kilograms, the combined mass, not 1,000 newtons. Times acceleration, and the net force is 2,000 newtons. Okay, so A equals 2,000 over 1,000 equals 2 meters per second squared. Okay, it's easy enough. Can we find the tension in the rope? All right, again, we now go from considering the total combined system to considering an individual part of that system, say this first car here, and we'll say, okay, F net on that car now, M2, equals the thrust force pulling it forward minus the tension force pulling it back. So Ft, the thrust, minus tension. So tension equals Ft minus F net. Okay, what's the net force on this particular object? Well, we find that from MA. And again, we use mass 2, just the mass of that individual object now. And the acceleration of the combined system is 2 meters per second. So we find that the tension is, sorry, that should be Ft, I don't know why I wrote that as F2. Ft minus M2A equals 2,000 minus 1,000, sorry, the mass 2 there is 500, times the acceleration, which is 2. 500 times 2 is 1,000, so it's just 2,000 minus 1,000 equals 1,000. So the tension in the rope equals 1,000 newtons. Okay?